We'll start the session in 1 minute. If Okay, so let's start the session. Okay, hello everyone. Uh, so today we are going to discuss about the week 9 lectures of the course Optimization Methods for Civil Engineering. I'm Balram Shah. I'm the PMRF TA for this course, that is Optimization Method for Civil Engineering. I'm a PhD scholar at Interdisciplinary Center for Water Research, ISC Bangalore. So let's start the session. But before that, what all we have studied till now, we have studied the classical optimization, like how we can do the optimization using the classical approaches, using calculus and some other methods, right? Simplex problem and all we have discussed. Then we move to the meta-heuristic optimization, and one of the method for meta-heuristic optimization commonly used is genetic algorithm. So we have studied about the genetic algorithm, that what is genetic algorithm and what are the process that is involved in the genetic algorithm, what are the features, like when we need to terminate, what are the criteria such as selection criteria. We have studied crossover, mutation, elitism and such that, and so on, right? So today what we will be doing, whatever we have done before this, whatever problem we have solved, those we have solved using hand, right? But most of the time nowadays we have computers, and also do we can solve the problem using some programming languages, such as maybe we can use R, we can use Python, we can use MATLAB and so on, right? So in the week 9 lectures, what we have seen, that we have uh, done this problem using the R software. Okay, so today we'll be, in the beginning we'll discuss a very brief introduction to R software. And as we know that in 2 hours it's very difficult, if you don't know anything about the programming language, it will be difficult. So before that, just go through some YouTube videos so that you can get a feel about how this programming language works, if you don't have any of the programming language knowledge. Okay, or else if you know any of the languages, maybe C, C++, or any of the programming languages, if you know, it will be very easy to understand the R software or Python, whatever. Okay, in this R software, we are going to just firstly we'll introduce about how is the syntax and all, some if else condition or statement, and then for loop, while loop and all, and simply variable, vectors, matrices and so on. Okay, and after that we'll move to that how we can solve the optimization problem using genetic algorithm. There are some library packages which we can use for this, right? So we'll be seeing all those. So let's start the session. Okay, so we have some questions or as the assignment question, but before that, so what is R? See, R is an integrated suite of software facilities which can do data manipulation, which can do data calculation, which can show you plots. That means we can have graphical display in it, right? So this R has an effective data handling capacity, storage facility, then several operators we can use to calculate calculate or do any operation on arrays, maybe in particular matrices and so on. Okay, we can do and we can analyze the data. Mostly this R is done used for statistical analysis. So for statistical analysis, it is one of the best software you can say, right? So for this R software, we can directly get the R software. You can just download and installation I'm not showing, because in the week lectures you will directly get that, and it is not very much tough to install the R software. So for that, what we use to for any of this kind of languages, so this kind of languages we use some IDE. What is IDE? IDE is a integrated, the full form is integrated development environment. So in this, what happened, so this IDE is kind of a software application that helps programmer develop some code which is more efficient and more effective, right? So it will combine many tools and features into a single environment. Okay, so we'll see that. So for this R, mostly we use R Studio as the IDE. So we'll jump to R Studio directly. So here you can see the interface of RStudio. Okay, just for this I'll just close the video so that it will not have bandwidth issue. Okay, so this is the interface of the RStudio. So here you can see 4 windows, right? This one is one in window. Sorry. So this is one of the window. So this is called the source editor, and this window is called the console editor. Okay, whatever we can write the code here also, we can write it the small operations here also. So mostly we do any of the languages thing here in the source editor, we can edit here. Okay, this one is the environment pane. So here we can see the history also if we have done something before, then some tutorials and all also you can see. This one here we can get all the files, then you can see whatever plots you will do, you can see it here. You can see all the library packages and all. So these library packages will come later. So for anything you can just search here. Maybe let's say if you want to search for loop, you can just write for and enter. So see here you will get all this: if condition, if else, then for, while, repeat. So like that, if you can get all the help from here. Okay, now let's start. So before that, what all we have seen. Okay, so let's start directly from the introduction to R. Okay, so in R, whatever operations we can do, we have seen we can do maybe addition, multiplication, or whatever, any kind of data analysis, whatever we can do, we can think of, we can do here. Okay, so before that, in the beginning, let's start with a variable. Okay, so what we do, we choose, let's say, some variables. If you want to do addition, what we can do here, can you see the fonts clearly, or else I'll increase the font? Okay, I'll increase the font only. Oh, I have to download some add-ins. Okay, fine, let it be. I hope you can see the font now at least. Okay, so let's see that. So what we have done here, we are creating a vector as a scalar quantity, let's say. Okay, so we are creating variables such as a, b, c and all. Now we are storing the value 3 into a. So what we are doing here, we can write this. This is what this is. A is storing the value of 3, so this is a equals to 3. So in R we can write both as a like this, a less than and hyphen. So this also means a equals. Okay, so we can write this as this, or we can write it as a this. So both are same, this one as well as this one, both will do the same work. Okay, and let's say if you want to comment any of the line that you have written, you just put one hashtag mark here and you can just comment it down. Okay, so we just want to add two variables, so we are storing the values of two variables, values in two variables, such as the first variable is a, in which we are storing 3, and the second variable is b, which in which we are storing -9, and we want to do simply the addition. Okay, so we are creating one new variable, that is c, which will have the value for added for a and b. So it will be a plus b equals c. So c will have the value of the a and b, right? A plus b. So just if you just run this, okay, either you can, if you are running here selecting this, it will only run this line. See, in the console you can see a equals to 3. Okay, and now let's say if you want to run all these lines, you can just select all this line, you can just put it run. Okay, so see, c is how much? -6. So 3 plus -6 -9 will be -6. So like that, if you want to, let's say, create another variable d as a minus b, so what it will be, just see, now if you don't run these lines also, then if you don't run these lines also, it will be fine, because now in the environment you can see the values of a is taken as 3, b as -9 and c as -6. Okay, so now anyway we have all the variables defined, a, b and c, which has these values. If you just run these lines, it will be enough. And just the shortcut key for run is control plus enter. So if you just press control enter, you will get the value. Okay, so d is how much? 12. A is how much? 3. B is -9. So 3 minus -9, that is 3 plus 9 will be 12. Okay, similarly you can do multiplication, division, everything. Okay, now if let's say if you are just keeping that variable itself, so now what we have done, we have defined d variable as a minus b. Now again, after that, if we define d variable as a multiplied by b, and if you just check that variable, now the last line whatever will be there, if in that we are storing new value, then the variable will have that value itself. Okay, if you just run this, see, now the variable value, that is value of variable d, has changed, that is -27. So 3 into -9. Okay, now after this, if you use d anywhere, the value will be -27. So if you are using the same variable again by mistake, it will only take the value which you have after or the latest one, right? Like that you can do multiplication, division, whatever. So now I hope we understood that how we can use a variable as a scalar quantity. Now let's move to a vector quantity. So a vector can be array, it can be number of arrays such as matrices. Matrices will come later, but before that, let's say we have simple array. Okay, so here a vector can be created in many ways in R. Okay, so it can be written as, so let's say we are defining a vector as capital A, and we are putting a equal c bracket mein 1:5. So this means what? It is creating an array with the values 1 to 5. Okay, now let's say if we run this line, see, a is what? A is c 1 to 5 has been run. Now if you see here in the environment panel, a is what? A is a integer array with values 1 2 3 4 and 5. So let's say if you want to see it here, you can just write a and just enter. Now see, a is a array of one row, it will be 1 2 3 4 and 5. So it is a one vector, values starting from 1 to 5. Now again, if you write it like this, if you consider one variable b equals 5 to 1, so what will be the new variable b will be, see here you can see it starts from 5 but it ends with 1, so it based on this one 5 to 1. So 5 4 3 2 1. Again, if you just write b here and enter, you will get 5 4 3 2 1, right? Other than that, if you don't have a sequence, you just want to put some values, you can put it manually also. See 1 2 3 4 5, or let's say I will change something, make it 13, maybe make it 25. Okay, so now if you run this variable, that is c, in the environment, you can see c is a number array with 1 2 13 4 and 25 as their element. Okay, now if you run c here, it is 1 2 13 4 and 25. Okay, this is one of the way. If you just want to generate a sequence, you can just use this kind of thing. If you just want to put values manually for all the elements, you can just put it like that. Again, if you just want a sequence with one difference, so you are defining the difference, so we can write it as, so let's say we are defining a variable d as a vector, and it should have sequence starting from 1 to 10, and it should be having a difference by 1. Okay, now let's run this line. It is what, so here we have d, right? So d is what, d is an array with the value starting from 1 to 10, so 1 2 3 4 5 6 7 8 9 10, and the difference is 1 for each of the element. Now again, let's say I have defined one new variable e, which is having a sequence of 1 to 5, so it will be from 1 to 5, but the difference here will be 0.5. Okay, now let's run this line. See, the new variable e is what, e starts from 1 and goes to 5. Okay, but how many elements do we have? 1 to 9, so we have 9 elements. See, 1 1.5, 2 2.5, 3 3.5, 4 4.5 and 5. And here why it is not like 1 2 3 4 and 5, because here we have mentioned that it should be, the sequence should be by 0.5, so the difference will be 0.5, so that's why 1 1.5 2 2.5 and so on. Okay, even if you don't take this c, what happens, let's see that. Okay, see what we have. Again, in this also, in this case also, we have one array starting from 1 to 7, so you can create a vector like this also. So there are several ways we have seen. Sequence, we can use this. If you want put manually, we can write this. If we want sequence but with a difference defined by us, we can write it like that, or we can simply write it like this also, but in sequence. Okay, now let's say you want to know the value of one element. Okay, and the position you will specify. So let's say I want to know the second element of the array or vector d. Okay, so we can just write d2. Okay, and if you just so see here what we have, d2 is how much, 2. See, in d what we had, d we have 1 2 3 4 5 6 7 8 9 10, and the second position is 2, so the value is 2. Now let's say if you want to just check maybe e4, so what will be e4? If you just run this, you see the e is a vector starting from 1 1.5 2 2.5. so in the fourth place, what is there, 1 1.5 2 2.5, so it should come as 2.5. Press Ctrl Enter. So see, we have got 2.5, right? I hope creating a vector and all is clear now. Okay, now we'll move to creating a matrix. Okay, so for matrix, what is the syntax? Syntax is, you can use this function, that is matrix. This is the data that you want. So in R, what we can do, let's say we have an Excel sheet or maybe CSV file, we can just import that into a variable and then use that also. Okay, so we are not going like that, but just to say that this data can be any data frame or whatever. Data frame also we'll see now. Okay, next is n row. N row means number of rows, n column means number of columns. By row as in if we want to okay, by row will come here. Okay, you'll understand here. And dim names as in dimension names. Okay, now we are creating a matrix A. Now again see, we are creating a variable capital A which we have defined before. So now if we store something in this variable, that is capital A, whatever was there before will be removed and this new thing will come into this variable, that is capital A. Okay, so here you can see, before that we have not run this line now. Okay, so what we have A as a vector of 1 2 3 4 and 5. Now what we have mentioned, let's say we are want to create a matrix with element 20 to 25. Okay, so the way we are creating here an array, we'll create 20 to 25 sequence, but the number of rows should be 3 and number of columns should be 2. Okay, so 20 to 25, how many values are there? 20, 21, 22, 23, 24, 25. So 6 values are there. Okay, so we have 3 rows and 2 columns. So let's just run this. What we are getting, see, we have got a new data. Okay, A is what? A is a matrix with rows, how many? 3 rows and 2 columns. Okay, if you just run A, see here you can see A is what? A is having 3 rows and 2 columns. Now here what you can see, the values, the sequence that we have generated starts from 20 here and it goes first in this and then is this one 21, then 22, 23, 24, 25. Okay, now you don't want the sequence like this, it should go by row. So it starts from 20 here and the 21 should be in the same row and then it should go into the next row. That is, here should be 22, it should be 23, we want like that. Okay, so the sequence should be by row. So what we are doing, if we don't mention this, if we don't define this by row, then it will consider the default one. So what is the default one? Default one is this one, that it will have the sequence by column. So see, in the first column first it took 20, then first column second value is 21, first column third value is 22, and then it moved to the second column and then the next sequence has been generated. Now let's run this line. So see, we have we'll just write B and enter. Now see, the sequence has been generated by row. So in the first row, first column, what is the value? 20, and next in the second, in the first row itself, the values is 21, then 22, 23. So you can see the difference. You understood what is the purpose of this by row. If you don't mention this, the default thing will come. Okay, now let's move on to the C bind. What is C bind? C bind creates a matrix by binding 2 or more vectors as columns, whereas R bind does the same, that it creates a matrix by binding 2 or more vectors but as rows. So here C means from C you can remember column and from R you can remember rows. Okay, yeah. So C is what? Let's create another variable, that is C equals matrix of 2 to 7. So the sequence will be 2 to 7. So this means 2 3 4 5 6 and 7. Again 6 values we have considered, and number of rows is 3, number of columns is 2, and by row is equals to true. This means what? It should create the sequence by rows. Okay, in the first row it will be 2 3, second row 4 5, third row 6 7. Correct? So we'll just run this line, and then C bind A and B. So what we are doing, we are binding 2 matrices, that is A is a matrix and B is a matrix, right? So let's bind A and C, because C just now we have created, it will so C I will write here so that you can visualize C also. C is what? 2 3 4 5 and 6 7. Now what we want to do, we want to join or bind this. First one is A, that is 20 23 21 24, all those, and this. So we'll bind these 2 matrices. Okay, and which matrices we are binding? A and C. So let's just bind this, control enter. Now see, you can see that A was what? A was 20 23 21 24 22 and 25, and C was what? 2 3 4 5 6 7. So it has just binded based on the column. So it has placed one column, the first column first, and the second matrix at the second. Okay, and how it has binded? It has binded based on the columns. So the first matrix they considered such a like first column, and the second matrix as the second column, something like that. Okay, you can just, to understand, you can visualize like that. Now here I have not stored this in any variable. Okay, so in the next one, what I am doing, I'm considering one new variable, that is d, which is r bind a and b. Okay, so now what we am doing, I'm considering this r bind, and we are storing this into a new variable, that is d, so that if we want to use that in any of the later lines, we can directly take this variable, or else we have to write the whole thing, that is r bind a b, something like that. Okay, let's just run this line. So we have d. If you just want to see what is d, see, now what we have done, we have placed it row wise. So 2023 21 24 22 25, and then 2021 22 23 24 25. This is a and b we have binded. Okay, so this way what we can do, we can bind vectors also. We can bind vectors, we can bind matrices, and so on. So now moving on to maybe matrix operations. So in matrix operations, we can do matrix addition, matrix subtraction, matrix multiplication, right? So let's say if you want to just add two matrices, that is a plus b. Okay, let's just run this. So now see what it has done. It has added a and b. So a was what? A was this one, and b is this one, right? Now 20, so what it has done, it has done addition element wise, that is 20 plus 20 is 40, 23 plus 21 is 44, 21 plus 22 is 43. So like that it has done addition. If you want to do matrix subtraction, that also you can do. Control enter. See, we have got the subtraction. So what here it is doing, it is subtracting the elements correspondingly. So let's say first row, first column, if we add, both the first row and first column will be added, both the second row and second column will be added, right? Something like that. Okay, next we move on to the multiplication. So let's say we are multiplying a and b, and we have e. So we are storing the multiplied value or the multiplied matrix into e. So let's just run this line, control enter. Okay, now if you just want to see, you can just make it like this. So what is happening, 20 into 2400, then 20, I have to check, let's see, it's 23 into 21, it's how much, 483, and so on. So what in this multiplication, what has been done, it has multiplied the elements correspondingly. So the first row, first column, whatever element was there, is being multiplied by the first row and first column of the second matrix. Similarly, second row, second column, whatever element is there, it has been multiplied with the second row, second column of the second matrix. Okay, but as we know that matrix multiplication is not like that. Okay, it will be matrix multiplication anyway, you know, I am not going to define all those. Just remember that while doing the matrix multiplication, the number of columns value of the first matrix should be equal to the number of rows of the second matrix, correct? Right? So that's why here a and b, what is the order of a and b? A is a 3 by 2 matrix and b is also a 3 by 2 matrix. So if you just want to do matrix multiplication of a and b, it is not possible, because the number of columns of a is how much, 2, but the number of rows of b is 3. So those are not same. We can't just do matrix multiplication. So that's why what I have done, I have taken the transpose of b. Okay, so T of b as in transpose of b. Now that I am storing in b itself. So the new b will be what? The transpose of the old b matrix. Okay, so what will be the order? It will be order of 2 by 3. Now what will be the new what will be the number of rows in b matrix? It will be 2, and number of columns in a matrix is how much? It is also 2. So matrix multiplication is possible, right? So now we are doing matrix multiplication. So how will we do? We'll just write it like that: a percentage multiplied by percentage of b. So this will give what? This will give us the actual matrix multiplication of a and b. Okay, just run this line. Okay, I have to run this both because transpose we have not done. Control enter. Okay, so now we have done the transpose. So the transpose of b is now stored in b, and e is what? Is a matrix which is having the actual multiplication value of a and b matrices. Just see the e. So now you see it is a 3 by 3 matrix because the number of rows in a is how much? 3, and number of columns in b is how much? 3. So that's why we have a matrix of 3 by 3. Okay, you can just check it by hand also if you want to do. If you want to just check, you can just check. I'll give maybe in calculator you can check. Okay, fine, you can just check, you will get the same answer. Fine. Okay, before moving on to the data frame, let's just see some of the assignment questions first. So the first question is, what will be the output of the following R code? X is 1 to 4 and x greater than 2. And this just by viewing also you can answer. What will be the answer? Or just let's do this in the okay, what was given? That x is a variable with 1 to 4 and x greater than 2, right? We'll just run this. Let's see what happens. So see, what is the output? It is false, false, true, true. This means what? So x 1 to 4, as in x will create a vector. So this is a vector starting from 1 to 4. Here you can see x is what? X is a vector, or if you just want to see x, enter. See, x is a vector with elements 1, 2, 3 and 4, right? And next line is what? X is greater than 2. So here we have given argument as x is greater than 2. So the first element, that is 1, is not greater than 2, so that's why we have got as false. Next is 2. 2 is also not greater than 2, so it is false. 3 is greater than 2, that is why it's true, and 4 is also greater than 2, this means it will be true. Okay, I hope this is clear. So let's see if this option is there. Yeah, so the correct answer will be B, that is false, false, true and true. Correct? Okay, now let's move on to the next question. Again, the output of the following R code. X is this, y, okay, a new variable has been introduced, or a new vector which has a sequence of 6 to 9, that is the element will be what? 6, 7, 8 and 9. Okay, x is greater than 2 and that's it. Okay, so let's see. 1 to 4, x is 1 to 4, anyway we have defined. We just need to define y as 6 to 9, right? I think there is some question issue because it should have more thing. Okay, so I think there should be something more in the question. Let me just check. Oh, give me 1 minute. Let me just check the question again. Oh, I think it should be what will be x by y, I guess. Okay, we need to find out the division. We'll just do that. See, okay, the question was x divided by y. Okay, so in this, while we are dividing two vectors, what will happen, as I mentioned before also, that the element wise division will be happening. So what we have, x, what is x? X is 1 2 3 and 4. And what is y? Y is 6 7 8 and 9. So if you see the division, that is x by y, it is what, the element wise division, that is 1 by 6. 1 by 6 is how much? 0.1666667, whatever. And then second is 2 by 7. If you just do 2 by 7, just can you just check and let me know? Let me check. 2 by 7 will be this. 2 by should be will be 0.285. 2 by 2 by 7, it's 0.285714, right? 3 by 8, it will be 0.375, and 4 by 9, it will be 0.444. So the correct answer will be this. Okay, so the correct answer for this will be B, right? Okay, the next question is two vectors m and n are defined as m is a vector again, that is C 3 2 4. So here we have manually given, that is 3 2 and 4 are the elements of the vector m, and next vector is n, that is having a vector of elements 1 and 2. What will be the output of vector z defined as z is equals to m into n? So what we are doing, we are just multiplying two vectors. But again, here note that we have 3 elements in the first vector and 2 elements in the second vector. So what will happen? Can you just do it? You just, or else I'll just show you. So let's do that. I'll just, so m is how much? Sorry, m is 3 comma 2 comma 4, and n is equals C 1 comma 2. You can use equal to sign also, no issue. And why we need to find a vector z that is equals m into n, right? So we'll just select these 3 lines, just run. Okay, so here see, there is a warning message. It's not an error message, but it's a warning message. What is that? That in m cross n, or m multiplied by n, longer object length is not a multiple of shorter object length, but still you will get the solution. Okay, it's not an error, it's like the shorter object length whatever is there. So here let's say we have 1 and 2. So here how many elements do we have? 2. Whereas in this one, that is the longer object length, is 3 2 and 4, that is 3 elements are there. So if let's say you have multiples of this shorter object length, so let's say you have 1 and 2, and this one is 3 2 4, and maybe let's say something 6. Okay, and now if you just multiply, you will not get any error message, but I'll show. See what happened? Okay, it just it happened. Now if you just want to see z, how much it is? It is 3 4 4 and 12, correct? So what happened here? Firstly, it has multiplied the first element with the first element of the second vector, that is 3 into 1 3. Then again second element with the second element of the second vector, that is 2 to the 4. Then again after the shorter object lengths size is finished, again it will start from the beginning. So here what we have 4, and it will be multiplied with the first element of the second vector. So 4 ones are 4, and then again 6 into 2 12.
So that is the solution here. But if we don't have the multiples, then what will happen? It will multiply. So 3 into 1, it should be 3, 2 into 2, 4, and again 4 should start, and 4 into 1. Okay, and why it was showing this? Because we don't have the multiples. Otherwise, because after this also we have a element, it should be multiplied, but as we don't have that, so it will only do what? 3 into 1, then 2 into 2, again 4 into 1, and that's it. Okay, we'll just see that. See, warning message is coming, that is longer object length is not a multiple, but you'll get an output, that is z is what? Z is 3, 4 and 4. Correct? I hope it's understood. So if you have the same length of the object, then what will happen? It will just multiply the corresponding elements. Now if one vector has a longer length or a longer object length, then what will happen? It will multiply with the shorter object length, but it will repeat unless and until it is finished. Okay, so as we have seen in the last example, that is 3, 2, 4 and 6 I have taken. So in that case it will be like this. But if we are just not giving multiples, there will be a warning message, but it will have the solution. Okay, so the correct answer will be 3, 4 and 4. Let's see. So the correct answer for this will be 3, 4 and 4, that is D. Okay, I hope this is clear. Okay, so this is coming to GA and all, but before that let us understand data frame also. So data frame is one of the important uh, thing in while doing the data analysis, because most of the work that we will be doing, maybe if you are extracting something from CSV file or Excel sheet, or maybe you are creating new vectors or matrices, you'll put that in data frame. Why? Because this data frame can have elements, not only the number type or integer type, but it can have any type of data. It can have text type data, it can have date type data, it can have numbers, it can have any kind of any type of elements it can have. And that's why mostly data frame are being used while doing the data analysis. Okay, so here we are creating one data frame. So A we are considering as, let's say, one data frame is equals data dot frame. So you have to use like this, data dot frame. So first column that we are creating is date column. Okay, so whatever will be the name or the text, if we are writing, it should be in double quotes. Okay, so this one is in date. Date equals sequence dot date as dot date. So this as dot date if you use, then only you'll get the date. So let's say maybe 18th of September 2024, and as date, so today's date I'm putting 23rd September 2024, and the sequence should be what? Sequence should be in days. Okay, if you write months here, and let's say if you are giving 1 year here, 2024 to 2025, it will be in months. Okay, so here we have put days as in it will have sequence as in days. So 18th September, 19th September, 28th, 21st, 22nd and 23rd. Okay, this one will be the first column. Next column we are writing it as rainfall values, let's say. Okay, so rainfall values, again we are creating a vector. So this is a second column, and this one will be the column name. That's why we have put this in double quotes. Okay, so the rainfall values are 51.2, 43.6, 10.25, 0, 0 and 62.3. Again the third column is rainfall type. Okay, so rainfall type is what? Rainfall type can be, it can be high rainfall, it can be medium rainfall, it can be low rainfall, or it can be no rainfall, right? So these are text file. So we'll see that. See what we have here. So we have created one new column, that is rainfall type, and as all the elements are text, so we are putting those in the double quotes. Okay, again this is a vector. Okay, so now we have created a data frame. We have not run, so we'll just run this. So now we have created a data frame, okay, with 3 columns, that is date, rainfall and rainfall type. Here you can see, here we have this, right? If you just open this, you will see date, rainfall and rainfall type. So if you just click on this, you'll get data frame, that is date is a what? See, 2024 9/8, 2024 9/90. So this means what? 18th September, 19th September and so on. These are the rainfall values given, and these are the rainfall type. So we have created a data frame. Okay, now with this we can just use this and do whatever data analysis we want. Okay, so, and let's say now you just want to know that how many um, days are there in between these two. Okay, this is maybe 18 September, or let's say how we can extract maybe any element from one data frame or something. What we can do, we can write. So let's just try that. Sorry. Okay, so here what we tried ki if I want to show only the second value uh, of the date column of the data frame, right? But here if we do it like this, it will show an error. What is the error? So this error can be of different type. It can be value error, it can be maybe text error, or it can be different types of error. So these error handlings and all, it it, it is itself is a like big topic. Okay, so we'll just try it. Let me see how we can do. If we can write it like this. Yeah, okay. Okay, so this is the number of column and it starts from 0. Okay, so if you write 0 here, a02 means let's say a is the data frame here, right? Now a0 as in the first column, as 2 as in second row. Now if you just run this, what you are getting? Numeric of 0. Okay, so with this we are only getting the number value, numerical value. Okay, so for text value you have to make it like that. So you just go to the help and then you can just see. So let's say if you want to get the I will go to the a data frame first. You want to know what is the how much these 19 September's rainfall is higher than that of maybe 20th September. Okay, so we'll just do minus, right? So first column, second row, second column, and second row minus second column and third row, right? We'll just control enter. Sorry. Okay, maybe we'll put this in something x. Okay, there is some non-numeric argument it is showing, or maybe we'll just put it like this. Okay, x and y was different. We have not run this. We'll run again. There is some issue, I think. Let me check what is x and what is y. X is correct. Okay. Sorry. Okay, so this one is considering the column and this one is considering the row, I think. Yes, correct. Okay, so 2 and 2. Now if you just run, let's see, yeah, 7.6, correct. So what we were after, I just wanted to know that what this 19th September rainfall, how much it is more than that of the 28th September rainfall. Okay, so sorry, how much is the 18th September's rainfall higher than that of 19th September rainfall. Okay, so what we did, we just, so this one is what, a12 as in 1 as in the first row and 2 as in second column. So in R, mostly whatever will start, it will start from 1. So this element, whatever, let's say, so here the first row will denote 1, second row means 2, third row means 3, and if you go by columns, this one is 1, this one is 2, this one is 3. But if you do in Python, it will start from 0, 0, 1, 2. Here it will start from 0, 1, 2, 3, 4, 5, like that. Okay, so here a12 means what, a1 means the first row and 2 means second column. Okay, so first row second column is what, first row second column is the rainfall value. Okay, and here in y, what we have stored, we have stored the second row and the second column. Okay, I'll write the question here. How much is the rainfall of 18th September greater than 19th September. Okay, so here what we are doing, see, y is what, y is a22, as in second row second column. So second row second column is how much, 43.6, and we are just taking the difference, and taking the difference, it should be 7.6. So it is showing 7.6. Okay, so now let's say if you just want to know the difference between two dates, so how much day difference is there in between first and maybe fifth rows, let's say. Okay, because it is a sequence, so it should be like that. So here again I am introducing x as a. So what we are doing, which row which column, so first row first column itself. Okay, so 1 comma 1, and then let's say y we are keeping as a first row but fifth column, sorry, first, okay, sorry, it should be fifth row and first column. Okay, and just you want to know the difference. Okay, control enter. So here see, the time difference is -4 days, because I am doing it from 18, 19, 20th, right? So we'll just make it y minus x, because later days we are checking, right? Now if you just say, it will have 4-day difference. Control enter. See, time difference is of 4 days. Okay, here it is showing the time difference, right? Okay, I hope all these data frames and all are clear. So now what we have, let's see. So now coming to the conditional statement. So you can use different statements such as if else statement. Then we can go for loops, because these loops, statements, conditions and all will help us to efficiently or write the program, so that it will be much faster. Okay, computation. So here what we are doing, conditional statement is, so we are putting one variable, that is x equals to 10. Now conditional statement is this, that is, if x is less than 0, it should be a negative number, else it should be a positive number. Okay, so here x is how much, x is 10, so it should be a positive number. So if you just run all these lines, control enter, see, x is a positive number. Again, if you just change this, let's say maybe -10, and if you just run this, see, x is a negative number. So here what we are doing, we are using the if else condition, that is, if x is less than 0, it will print this, else it will print this. Okay, so we can use multiple conditions also. So if this is this condition, so this here the condition is what, x less than 0. This is the main condition. Now we can have different conditions, right? If x is let's say we have two variables, x is minus 10 and y is something, okay, that we have later. Okay, fine. So for multiple condition we can use logical operators such as ampersand two times. So this two times ampersand means what, means and, okay, in R, whereas two times this means or. Okay, now this stands for not. So if you want to write not equal to, you should write like not equal to. Okay, if you want to not greater than, it should be like this. If it should be not less than, it should be like that. Okay, and such that. So we'll see that. So we have three variables now, that is x equals to 3, y equals to 5 and z equals to 2. Now we have multiple conditions that if x is greater than y or x is greater than z, then print x is greater, because see, x is greater than both here, right? Then we'll print that x is greater, or else we'll write that x is smaller. Okay, so here x is how much, 3, y is 5 and z is 2. So here just by visualizing we can see that x is how much, 3, which is greater than 2 but not greater than 5. Here what we have done, we have written or. This double vertical line means or. Okay, so if x is greater than y or x is greater than, so in any of the case, if that is satisfying, it should be x is greater, or we can will get x is smaller. So let's just run this. So what we are getting, we are getting x is greater, because one situation is getting satisfied. So if you just write and, okay, and just run this again, what will happen, let's see x is smaller, because here you'd have to satisfy both the conditions, that is x greater than y and x greater than z, then only it will print x is greater, otherwise it will print x is smaller. So here 3 is not greater than 5, hence one situation is not getting, this x is greater than y is not satisfying, hence we are getting x is smaller. Okay, I hope this is clear. Okay, so this one was if else condition. Now we can directly use only if else. So when we use this if else, when we want to check condition on a vector for every element and select elements from vector. So how we can write that, we can write if else the condition. So here conditions were what, x greater than y or x greater than z. Before that what was the condition, x less than 0, like that we can write the condition, then true vector. So if that condition is satisfied, then what will be the situation, we can write here, or else we can write the here. So if this condition is not satisfied, what should be the case. So like that we will see this. So we are creating one vector, that is v, as a sequence of elements from 1 to 6. Okay, now if else v, that any value in this v, so this again, this double percentage means the remainder. So the division, if you divide the element of v with 2, the remainder of it is equal. So here double equal to means what, equal to, whereas if we are using here equal to, that is x equals to 3, this means what, 3 is getting stored in x, but double equals means equal to. Okay, so if we divide the element of v with 2 and the remainder is equals to 0, then it should be even, or else it should be odd. Okay, so just let us run this. See, so the first is what, first is 1 is not even, it's odd, 2 is even, 3 is odd, like that. Okay, I hope if else is clear. Okay, like that, if we can, you can use else if also, so that also can be used. Again in loops there are several loops are there, for loop is there, while loop is there, do while loop is there, and so on. We'll just see one or two loops. Okay, so here see, for I in 1 to 5, if I mean I is moving from 1 to 5, y will be I to the power 3 divided by 3, and we have to print y. Okay, so here what is happening, first I will start from where, I will start from 1, and then it will enter into the loop. Then y, at first the y value will be y equals to 1 to the power 3, because in the first scenario I is how much, 1, so 1 to the power 3 by 3, that means 1 by 3. Then again when it will print y, and then again it will come out and it will get to here. Again 1 is done, next is what, 2, so again the value of I is now what, 2, it will enter, it will be 2 to the power 3 by 3, that means 8 by 3. Then it will print 8 by 3. Again it will go and it will keep on doing that till this, that is 1 to 5. Okay, and after that it will terminate. Just let's see how it works. See, first one is 0.33, that is 1 by 3. This is 8 by 3. This is 3 to the power 3, 3, 3, 9, and then 27. 27 by 3, 9, and such like that. Okay, if you just increase this, if you write this as 1 is to 4 maybe, then, or maybe let's say 6. Okay, and you just run this, one more will be added. See, 72 is coming. Okay, you can do this with while loop also. We'll see that how. We are storing y as 1. So now the value of y I is how much? 1. Now while I is less than equals to 5, it will enter. Now the value of I is what? 1. So 1 is less than equals to 5, it will enter to the loop. Again y will be 1 to the power 3 by 3. It will print y, and then I will be incremented. So I, next I should be what? Now I is 1, then 1 plus 1 will be 2. So it will go, it will again check this condition, that is 2 is less than equals to 5, it will enter. Again at the end it will become 3. So I equals to 3, again it will go, 3 is less than equals to 5, it will enter, it will do the operation, and again it will, so it will keep looping unless until this condition is not satisfied. If this condition is not satisfied, it will terminate. Okay, we'll just see that. See, we are getting. Now let's say if you're not writing this, that is I equals to I plus 1. So every time you enter this loop, I is always 1, right? So it should go into a infinite loop. Let's see. See, it is not stopping, it is going in an infinite loop. Okay, we'll just stop that. I hope you understand why it went to infinite loop. Okay, so if you just run this, you get the 5 values. Okay, so I hope introduction is like clear. You will understand it better if you practice on your own. The more you play with this kind of software, the more you learn. Okay, so let's move on to the main topic, that is the genetic algorithm that we were doing. So we'll do some optimization problem using genetic algorithm. Okay, but using the R software. So let's move. Next we'll go to Unconstrained GA. Okay, so before that, for doing this genetic algorithm and all, we have to install some packages. Okay, what is this library packages and all? So the function that we have just created, if you see this introduction to R here, this is kind of a loop that we have created, right? So this is the function. So like that we can create some functions also using functions, that is FUNCTION function, and if you write bracket, and then in bracket you can write the argument, and then you can create the function. It can have several equations, it can have several arguments, it can have several loops and all, and with that you can just create a function. Okay, so let's say if you want to make a normal distribution, okay, so you can create that function also. So that is one kind of function. And after doing all this big data these functions in a code, we can put that in one package. Okay, and that is called as kind of library package. So you can also create your own library package. Okay, so for using those library packages, so here what we are seeing, we are using a library package called GA. So GA as in genetic algorithm. Now in this genetic algorithm there are several functions that has been there. If you want to just see that how this packages was there, you can just write GA and enter. So genetic algorithm. So see, so this has been created with several arguments. If you just go, it will here in help you will get everything, all the documentation will get here. So what all arguments are there, then what is all those arguments, what is type, what is fitness, and all it will be written here. Okay, you will get one example also. See, we just to run, you can get examples just to practice. Okay, and all the references also you will get here. Okay, so this help section is a very useful section for any new thing that you are learning. Okay, so anyway we know what is genetic algorithm, what is that, what are the types, because I said that it can be different different process we can use, right? So here we'll use so for encoding, you remember we have done binary coded encoding, we have done real coded encoding, and there are several other encoding also. Here you can see permutation encoding is also there, but this is out of the scope of this syllabus, so we are not going into this kind of encoding. Okay, so we'll do that. And for installing, what we can do, you can just write install.packages. So you just write install.packages and write the package name in double quotes. Okay, so for any installing any package, we can write install.packages, and the package name, whatever name is given by the creator, it should be like that. If G is capital, it should be in capital. Okay, so it is character specific. So in the double quotes, as I have installed, and if you run this line, you'll install the package. Okay, so as I have installed in my system, I'm not installing it again. Okay, after installing, what you have to do, you have to call that library or you have to call that function or the package, let's say. So how will you call? You will just write library and GA. So GA is the package name. So how will you load the library package? Library in bracket, you can write the package name. Okay, so library, and then now moving on to the problems. Okay, so let's say you have a function that is x square plus x into cos x. Okay, you want to maximize this problem, okay, without any constant. So you don't have any constant, you want to get the maximum value of this function, that is x square plus x. So here what we are creating, we are writing a function, we are taking a variable f in which we are creating a function. So function is with this variable, that is x, and the function will be this, that is x square plus x into cos x. So like this we can create a function. So function of the variable, maybe if two variables are there, write x comma y, and then in the second bracket you can write the function. Okay, so this is the function, that is x square plus x into cos x. Okay, so and next is curve. So we are first plotting the curve. Okay, running GA, we are coming later. First we'll plot this curve and check that how this curve looks like. So which function you want to plot? F function, right? The lower bound of the function should be -10, I have just kept, and upper bound should be 10, and should be 1001. This we'll see. The label of x will be x, y label will be f of x, and color will be blue for the curve. So just run this, let's say. See, in the plots you can see now. So x label is what? X, y label is y, f of x, as we have written here. Whatever you can write here, you can write anything, okay, for labeling. And this one is how the curve looks like. Okay, 0 is here. Okay, like that you can create. Now what we have to do, we have to optimize this function using genetic algorithm. So the syntax of genetic algorithm is such like that. So in help also we have seen, see, genetic algorithm type, then we can write fitness, so many things, lower, upper, n bits, population, and so on. Okay, population size we can write, population crossover we can write. So this is probability of the crossover. You remember we have read about the probability of crossover, it should be high, and probability of mutation should be low, and such that. So there are all the functions, you can see all the arguments and all. Okay, so we are using that. So GA is, see here, we have to use GA for getting the genetic algorithm. So GA type is real valued, so we are just considering the real value, not the binary valued. Fitness is f. So as I said that for while doing the genetic algorithm, the objective function will be what? The fitness function. So here this is my fitness function, and this is stored in which variable? That is f. So that's why fitness is f. Lower is -10 and upper value is 10. Okay, so just run this line. Okay, so see, there are total 100 iterations. Okay, so we have not mentioned any number of iterations. This is a default value. Okay, if you don't mention the number of iterations, it will only have 100 iterations. Okay, and now let's see the summary of this. Control enter. Now see, if you see the summary of this, it has done the genetic algorithm. Type is real valued, that was mentioned by us. Population size 50. This is again default value. Okay, if you don't change the population size, it will consider a population size of 50. Number of generations is 100. Elitism is 2. Crossover probability 0.8. You can just change all those if you want. Okay, we'll do that. search domain was between -10 to 10, and now we see the results. How many iterations it did? It did 100 iterations. And the fitness function value, that is f of x, we are getting as 47.70562. At what point? At the point 6.560499. Okay. Now if you just want to know the solution, so write ga@solution. See, you are getting the solution only 6.56. At 6.56 you will get the maximum value. Okay. Now if you want to just, so where we are getting 6.56, something here. Okay. And the value, maximum value is here, right? In the plot you can see that between -10 to 10, this is the maximum value, right? So it should be something near to 50, and it is coming as how much? 47.70562. So you just want to, for visualization, we'll create a line here and one dot here. Okay. So AB line will create a vertical line. So V as in vertical line of the GA solution. Color will be red. And with this points, what we are doing, we are creating a point. Okay, at GA solution. GA solution is what? 6.56 and GA fitness value. So we'll create a point here and a point here. And color will be red, the size will be 20, and we'll plot the GA again. Okay, so let's run one by one so that you can understand. See, it has created a vertical line. Okay, now let's just run this, control enter. See, it has created one point here, right? And if you just plot the GA, now we are plotting the genetic algorithm, right? So we have how many generations? We have 100 iterations, right? Sorry, number of generations is 100, so that's why it is showing 100 generation. And fitness value starts from 0 to maybe something 50. And in the beginning only, you see it has, here you can see, if you zoom here you will understand. See, here it was at a low value, then it started increasing, it was constant, again it started. After this point, after this generation, maybe let me see, after this generation, maybe after 10 or something, it took a constant value at the maximum. Okay, so like this you can get the solution. Now as I said that in this summary, whatever we have seen, the crossover probability, mutation probability can be given by us also. So that we'll do, we'll specify some more argument. So GA is GA type real valued again, fitness F, lower is -10, upper is 10. Population size, now we are fixing, we'll say that population size is 100. Okay, here population size and default was how much? 50. Okay, probability of crossover we are keeping as 0.9. Probability of mutation we are keeping at 0.05, and default was what? 0.8 and 0.1. And maximum iteration we are going for 20. Okay, so let's just run this, control enter. So see how many iterations we did? We did only 20 iteration, and still we are getting this. So as you can see, at 20 iteration also we can get that. So summary, if you want to see, just see, you'll get all the summary. And again, if you just want to see only the solution, only the solutions. Okay, now let's say whatever iterations we did, so at every iterations, if you see this thing, at iteration 1 the mean value is this, the best value you are getting as this, mean value is this, best value is this, mean value is, so at every point we are getting different points and different function value. Okay, and we just want to monitor that at what iteration where is the point. Okay, if you just want to monitor that, you can just create one function, and we are naming that function as monitor. So monitor is a function with object. What all objects? There should be curve, whatever we are plotting, f -10 to 10, and you can paste the generation, and then points will create. So all the points that will be create for each of the objects will be given. Okay, object population is the x value, and object fitness is the y value. The size of the point will be 8, and color column will be 4. Okay, and all this, and system should sleep at 0.2, so that otherwise it can't see if you don't provide this. So just run this. Now we have created one more function. Here you can see the functions. Function is monitor. Okay, now you'll use this monitor function. So again, so GA type will be real valued, fitness F, lower -10 and 10. Monitor we're keeping as monitor. Now if you change the name of the function here, if you write something like tonitor, then you have to write tonitor here. Okay, So just run this. So now see, you can see here that points are changing at every generations, right? And till what generation it will go? It will go till 100 generation, because default is 100. If you don't specify here the generation number of generation, it will go till 100. And see, as your generation is moving, the points are mostly moving towards the maximum, right? And because of the mutation, you can see other points also. And here also you can see at x point how it is moving. Okay, and at 100 generation you are getting most the value here, some of the because of the mutation. Okay, I hope this is clear. Now if you want to see the summary also, you can see. Okay, summary and solution again. Okay, that was one problem. Now let's move on to the next problem, let's say. Okay, so now we have a 2D problem, let's say. So 2D problem as in we have two variables. So if you plot that, it will be a 3D figure, right? Because we have two variables, correct? So here we'll do that. So function with x1 and x2. x1 and x2 are two variables, let's say, and the function is what? x2 plus x1 square. Maybe you can write x1 into x1, or you can write x1 square also, whatever you want, minus 11 total square plus x2 square plus x1 minus 7 whole square. Okay, so this is the function. Now the function is created, right? Yeah, correct only. Okay, so just run this. Let me just run this. So a new function has been created. See, the function is what? fp. Fp is having a function with variables x1 and x2. Now we are writing x1 equals to x2. So both are a vector, let's say starting from minus 6 to 6 by 0.1. So it will be, first it will be minus 6, then minus 5.9, then minus 5.8, and so on till 5.8, 5.9 and 6. Okay, we'll run this. If you just want to see x1, see x1 is minus 6, minus 5.9, minus 5.8, because we are given by as in difference, right? So till 6. So both x1 and x2 is having the same vector. Okay, in both the vectors, that is x1 and x2, this is stored. Now the function fp is outer x1 and x2 and fp, let's say. Okay, so with this persp, what we can do, we can plot one 3D figure. Okay, so 3D figure with x1 or x as x1, y as x2. So x and y and z will be there, right? And z will be this. Z will be what? Z will be the function. Okay, theta and phi are the angles. So you can change this and you can get other angles. So we'll see this first. Wait, control. Okay, we have not. Now you see, you can see a plot here, right? So this one is x1, this one is x2, and this one is fp. Fp is what? Fp is z, let's say. Okay, so here, as because we have given 30 and phi equals to 30, if you want to change this, let's say you want to keep it as 60. Okay, and if you just run this, see, the angle will change. See, now you can visualize this from this side. If you want to change this to 90, so the whole thing will only show you this part, right? So if you just write 90 and run, see, you can only see this in this view. Okay, so like that, if you want to change, you can just change anything and just run. Okay, so with this we got the 3D figure. Now as I said, that this 3D figure can also be visualized in the form of contours. We have seen in many of the classes, right? So we can create or plot this contour also. So contour x, y and z, and levels is 200, and column the color is blue. Okay, just plot that. See, now we can see. So we have not given labels. You can write x lab, or to give the labels also, x labels, y labels. So here what we can see, we have this as the same the 3D plot that you have seen here. This 3D plot, but in the form of contours. So we can have values here, minimum value, let's say minimize. If you want to do minimize, value can be here, it can be here. No, here it will be a maximum value, it will be minimum here, it will be minimum here, here it will be a maximum value, maybe 180 or something. Okay, whatever. Now we'll just run the genetic algorithm to get to the optimized value. Okay, so the function is f function. So what was the question? Let's see if we have any questions. So we have to minimize x square plus x plus 1 sin x plus sin 2x, and if this is given, okay, following code is given, you can just use this code and get it. Okay, but before that we'll just go through some questions that we have seen. So again, um, we can't write this xy like this for genetic algorithm, so what we'll do, we'll write the functions like this. Okay, so just for plotting we can use like this, but just to write it as, so x will create a vector with two variables, that is x1 and x2. Okay, so x1 and x2 are as in x and y. So here whatever you can see, x1 and x2 will create these two as two elements in a vector x. Okay, so here what we are doing, if you don't specify anything, genetic algorithm mostly will give maximized value, right? So that's why, just to minimize, if you want, you can put negative sign, -1. So -1 into whatever functions we can write, we will write in the form. So x2 as in uh, the second value or the second element of the vector x. So we are considering the second vector, sorry, second element of the vector x as maybe y or x2, let's say, and first element of the vector x as x1 or let's say x. Okay, so we'll write the function, and again simply whatever we have done as in genetic algorithm, we'll just use like that. Okay, we'll run this. So we have made a function. See, if you see here functions, you'll get the function as f. This function is a new function, not the old function, because we have again did that with the same variable, right? So we'll do the genetic algorithm, control enter. So it has done all the iterations till 100. Now if you just want to plot the contour of the final one, see, this one is the final contour that we can see. This is that function itself. Okay, then if you just want to see the final point, see, for this, because genetic algorithm, it is considered some iterations and some values for the um, mutation and crossover. So with that, we got this as the minimum point. Okay, so if you again do it, it might get, because we have four minimum points, as in say here, here, here and here, right? So for that you can get points here or here or here or here. Okay, based on wherever you are going. And then if you just want to see the summary, you can see the summary. So the x is 3 and y is, so correct value, if you see, it should be 3 and 2. Okay, so with this genetic algorithm we are getting x1 as 3.00097 and x2 as 1.998638, and the fitness function value is how much? Minus 3.99 into 10 to the power minus 5. Okay, so it should be 0. Okay, so it is not exactly 0, but it is very less. 3 into 10 to the power minus 3 into 10 to the power 3.99 into 10 to the power minus 5, right? So if you just want to see the solution, the x and y value, you can just see like that, right? Now again we want to monitor that how the points are changing on this. Okay, so again we'll make a function, and we are just plotting a curve and then points and sleep. We'll just run this. I hope this whole genetic algorithm is clear, because whatever we have discussed, we'll do that only for different objective functions, right? Now we'll just run that again. Okay, so there is some issue with x1. Let me check. What is the issue? Okay, okay, it was x, right? Where did I keep that? Somewhere x1 I have written in place of x, I think. Yeah, it should be x1. It is a vector with x1. It is a vector with x2, correct? Now let's try. Array in sequence or integer from to length. must be a finite number. Okay, curve of x1 and x2. Okay, from to fp correct only minus 6 to 6, 6 to 6 monitor. Okay, we'll move to the next problem. We'll see if there is any issue in this, because it is anyway showing here monitor is there is some issue. We'll see in the later. Okay, now to the questions that was there with us, right? So we have to minimize this function, that is x square plus x plus 1 into sin x plus sin 2x, and the range is given as minus 10 to 10. Okay, I don't know this following code. I have written something like this only. Okay, okay, so let's see. The function is we have to minimize this function, right? So that's why I have put 1 minus here. Okay, so the function is this, and the curve should be, the lower bound range is given as minus 10 and 10. Okay, we'll just plot this first. Control enter. See, the curve looks like something like this. Okay, and the range is minus 10 to 10. We just write color equals to blue, you'll get that. The color also, color is, let's say, blue. Okay, we'll get the blue curve. Fine. And now we want to monitor also. So monitor we have seen, so we are not going what all arguments are there. And now we'll do the genetic algorithm. So control enter. Now you see the points are moving for every iterations. Here we have not mentioned any iteration number, so it will go till 100. So see, most of what we want to do, we want to minimize. It should be at this point. Let's see. Okay, if you see the summary, at 10 we are getting 58.74. okay, we are getting the maximum value. What was the question? We have to minimize this function. Okay, so if we don't give minus here, let me see what happens, because it should have minus. So in this it will go line by line, that's why it is doing till here. So see, okay, so the function was like this, as because we have plotted the curve as minus only, that's why it was coming opposite to this, right? So the minimum value was correct only at x equals to 10 only. What was the value? Maybe at x equals to 10 we are getting the minimized value, right? So again, if you see the summary here, it is at 8 we are getting 72. Okay, so with minus here, what we are doing, we are changing the curve. That's why you can see the opposite curve here while doing this. So if you just make it minus f, let me see if it works or not. Okay, no, so you have to make it f. Okay, so the correct answer will be that only, but just it is because here we are putting minus, right? So the curve whatever we can see is the opposite of the function that is written here. Okay, so the answer anyway will come correct, and we are putting AB line also. We'll just do the whole thing. So the minimum point will be here, because the function was something like this. Okay, because of the minus, it has just got opposite of the whatever was the function. So at this point the minimum function should be there, and this point maximum should be there. So let's see how much we are getting summary and all. After 100 iterations are done, then only it will go to this line and this line and this line. Okay, yeah, see. So how much we are getting? 9 point at 9.996 something, you're getting 59.07. Okay, so this one will be minus 59.07, as we have kept minus as a function, so we are getting the positive value. Okay, so at this here you can see the line, the dash line. Can you see that? That is the AB line. So here we are getting the, okay, so here we are getting the minimum value, not here. Okay, here we are having the most of the points. Okay, so this one, so the answer will be what? Answer will be, how much we were getting, 9.99, so something like that it should come. Here I think we have mentioned more things, right? Let me see. Yeah, so here function we have not kept minus, right? So if you do that, how much we are getting, 8 point something, right? So if you just use that function and just do that, how much we are getting, we'll just run. Yeah, so you should get the maximum value here, at 8.05 something like that. So the answer will be 8.05a here. Okay, next, find the global minimum of the function using GA package in R programming. Function is given as 0.26 x square plus y square minus 0.48 xy. Let's see. I have done that. Okay, so what we have to do, we have to again minimize the function. Okay, again simple, a similar thing we are doing, that fp we are defining the function, and then we are keeping that in one vector, because the range is minus 10 to 10, we are making so many points like that. Okay, so just to see the 3D plot and all, I'll just show you. See, if you see the 3D plot, wait, should come. Yeah, so this is the 3D plot. Okay, and this is the contour plot for the same one. Okay, so here some, I hope the minimize function will come, maybe at 0 only it will come. So let's do that using genetic algorithm. So this I did just for showing you the 3D figure and the contour plot. Okay, now just do the genetic algorithm thing. We are not monitoring, so we'll just do that. 100 iterations done. We should plot the contour also. Okay, and point should be there. Yeah, see here the contour plots has been done, and here points we are getting here. So here we are getting the value at x equals to 9.23 and y equals to 10, we are getting the fitness function value as minus 3.84. Okay, now if you want to just monitor that also, we'll do that. Run. Okay, there is some issue with the monitor again. I don't know. Okay, let me check why this monitor is having any problem or what. It's rug, everything we are creating, but we have to create the rug also. Error in dimension mismatch. Okay, so there is some dimension mismatch. So with this, how much we are getting? 9.23 and 10. So let's see if the answer is there. So how much we are getting? F00 as 0 or what? Okay, no. Okay, so do it. Let's do it again once more. I don't want to see this. No, I want to see the summary also. Okay. Okay, here minus 0.26 was there, right? If I don't keep that as minus here, let me see how much we are getting. Okay. Okay, we should get f. Okay, we don't have to get the minimized value. Find the global minimum. So at 5 f00 is how much? 0 and all, right? So the correct answer would be A. Next question is this one. Okay, so this you can do on your own also. We're not going to do that. Okay, so this one was still unconstrained optimization. So let's move on to the constraint optimization, because what was happened, package G required. Okay, we have done this, so we don't need this. Okay, so again, see, if I am doing into a new script, again I am loading that library function, that is GA. Okay, so we'll do that. The function is maybe something like x1 minus 2 square whole square plus x2 minus 1 whole square. Okay, and for this we have two. Okay, let me check if I have it here. Okay, no, this should be one. So we have two constants, that is, here I have written it something like x2 minus x2 is equals to 2 minus x. Okay, so it's like x. Okay, I'll write it here. Maybe the constants are constraints sorry constraints are, first constraint is what? mm, X is here, so let's say x1, or I will write x and y. Okay, x plus y minus 2 is less than equals to 0, and second constant is what? X, no, x square y minus x square should be less than equals to 0. Okay, so these are the constant, and it has been written is like that. We are considering y as x2, let's say. So x2 is equals to 2 minus x, so we can write y as here 2 minus x, right? So that's why x2 is 2 minus x and x2 is x square here. So here y is x square. So these are the constraint we have written, and the range for the constraint is given as -5 to 5. So the lower bound and upper bound of constraint is -5 to 5. Okay, and these are the controls. Let's plot this first. Okay, so see, so this one is a function. Which function? That is x1 minus 2 whole square plus x2 minus 1 whole square. So this blue lines that you can see is the contour plot. Okay, so the way we have done the contour plot before, same we have done here. Okay, now these two black lines that you can see are the constraints. Okay, so the first one is the linear line, and the second one, that is y minus x square, is this one. Okay, so if you don't consider these constant, the point should be here, the minimum point, right? But now if we have constant, it should be something like here. Okay, so we are creating one function, let's say f, and the constant, how we are putting constraint, again see, f is a function of, so in that f1 is the objective function, the way we have written like that, this you know anyway, right? And g1 is the first constraint, that is x plus y minus 2. So see, x plus y minus 2, and g2 is the second constraint, which is x square minus y. So it should be x square minus y. So as it is less than equals to 0, if you write minus also, it will be same. So it can be minus x square plus y, or x square minus y. Okay, so these are the two constraints. So we have written the objective function, we have written the first constant, we have written the second constraint, and now what we are saying, that this function f, we are putting if else condition. We have seen if else condition before, right? So if else, the first constraint is less than equals to 0, and so here we have kept, and the second constraint is less than equals to 0. Which function need to be applied? That is this function, that is the objective function, and it will stop with the precision of 10 to the power minus 4. Here minus e to the power minus 4 means, if you write minus 1 e to the power 4, this means 10 to the power minus 4. Okay, so let's just again after that it's same, the GA and all. We will just do this. Okay, so GA is done. We are getting iteration 150 because see, we have mentioned that maximum iteration should be 150 and population size should be 100. Okay, now if you want to see the points, so here you can see the point. This is the minimum point. Okay, and if you want to see the summary, control enter. You are getting x1 as 0.98 something and x2 as 1.012. If you only want to see, and the fitness function value is minus 1.03. Okay, if you only want to see the solution, then we can just write the solution. Okay, and like this, so this is one of the example, and like this what you can do, you can do the constraint optimization. Maybe if this is having a constraint optimization, you can do that. So if you do, this is also unconstrained problem. If you just do, you'll get f13 as 0. Okay, I don't have any constraint optimization. So till this, I hope everything is clear. If there is any question, you can ask. If not, we'll stop it here.